Okay, guys. Are you able to see the screen? Screen is clear to you? Give me a yes and no in the chat box. Okay. Okay. So good afternoon, students. Once again, I welcome you all in this class of physics. This is our enable class. Okay. And in today's class, we are going to solve some of the problems related to work, energy, and power. This is a very important chapter by the point of view of your examinations also and your CBSE boards examination. Okay. So both point of view, this chapter is pretty good. Clear? So we have to focus on that chapter. We will going to solve some numerical problems on this and see the concept behind them. Okay? Clear है सभी को? Yes and no in the chat box. Okay, I'm waiting for a response. Then we will proceed with the very first concept. Okay. So this is the question discussion session. Now the very first question or the very first thing that you need to learn in work, energy, and power chapter is what is work done by the way. Okay. So work done is the force into displacement we all know. Okay. If we define the work done, how we are going to define the work done? It is the product of force and displacement. Okay. But which product? It is the scalar product or dot product. Okay. So the amount of scalar product of force and displacement gives you work done. Clear? Like you can see this particular man is pushing this block in the forward direction, pulling this block in the forward direction with some angle theta. Okay. And he displaces this block from here to here. So this will be the value of displacement, let's say S. So what we can say, the work done by this man here is F vector dot D vector, which is, if you open the dot product, it will be F D cos theta. You can simply arrange it as F cos theta into D, which means only F, whatever the component of force in the direction of displacement is, that you have to take that particular component. Clear? So always remember this. You have to take the component which is in the direction of displacement. Okay, parallel or anti-parallel, but you have to take that particular component which is in the direction of your displacement. Okay, so as you can see here that this block is being displaced in this direction, so that is why we are taking f cos theta as the component of force. Okay, now if I just show you, this is the question, but in this question here, the force is mentioned is 20 plus 10y, which means force is a variable quantity. Okay, force is variable. So what, how to calculate the work done when force is variable? So when force is variable, in this case, what we will do, we will calculate very small work which is given by f dot dx or ds, whatever you want to take, and then you integrate it and put the limit from where to where you have displaced the object. Let's say x1 to x2 you have displaced the object, so you will apply that from x1 to x2 integration f dot dx. Okay, clear है? So as you can see in the question, this question I am going to solve it for you. A force of F is equals to 20 plus 10y acts on a particle in y direction, where F is a Newton and y in meter. Work done by the force to move the particle y is equals to 0 to y is equals to 1. देखो, as I have said, that limit will be provided to you. So this displacement is being in the direction of y. ठीक है? तो ये जो displacement हुआ है, it is being held in the y direction. So we can say that it is f dot dx, f dot dy. Okay, clear है? So y की limit we will put 0 to 1. Clear है? So we can simply arrange it f dot dy. If this displacement is, अगर ये displacement x direction में होता तो हम क्या करते, f dot dx. ठीक है, but this displacement or this force is given as 20 plus 10y, and displacement is also, particle is also displaced from y is equals to 0 to 1, which means displacement is happening in y direction. So that is why we can say f dot dy. Clear? Now, what is the expression of f? It is 20 plus 10y into dy. ठीक है, look, so 0 to 1 you can put after the solution of it. So you can distribute the integration, that 20y plus 10y dy. So it is 20y 0 to 1 plus 10 y dy का integration will be y square by 2, and limits are 0 to 1. ठीक है, so it is 20 plus 10 by 2, 2 5 are 10, so it will be 25 joule. So 25 joule will be the correct option for it. How many of you have got this? Tell me in the comment box how many of you got this. Okay, everyone understand this? There is no problem with this. If you have any kind of doubt, you can ask right now. Okay, clear? And this question is from NEET 2024. Okay, the re-examination that is being held, it is from that particular question paper. Clear है सभी को? Anyone any kind of doubt? या जेएनवी में नहीं कोई बताओ क्या डाउट? What is the doubt? You can unmute yourself and then also ask what is your doubt. Then we will move further. Okay. Now this one. A body initially at rest and sliding along a frictionless track. Okay, I can explain the last step हो. देखो, we have taken this integration f dot dy, put the value of f which is 20 plus 10y, then we segregate this, we distribute the dy over 20 and 10y, so 20 dy plus 10y dy. Now we have just integrated, so 20 is a constant, integration of dy will become y, limits are 0 to. Similarly, integration of 10 is nothing because 10 is constant, so integration of y dy will become y square by 2, limits are 0. When you put the value of limits, so it will be 1 minus 0, 20 into 1 minus 0 will become 20, plus 10 into y square by 2, yani 1 square by 2, yani half, minus 0 square by 2, which is 0. So half minus 0 will become half. Half say we can cancel this. 2 5s are 10. So 20 plus 5 will be 25 0. Okay? So that is the answer. Clear? Now, a body initially at rest and sliding along a frictionless track from a height h just completes a vertical circle of diameter AB is equals to D. So this circle has a diameter capital D. Okay? The height h is equals to, what is the height that we require in this plank? Okay. What is the height that we require in this plank? H. So that what is the height that we require to reach at this point? Just complete करने के लिए circle को we at least have to reach at this point. So what we will do, we will just apply the conservation of mechanical energy. What is the conservation of mechanical energy? Conservation of mechanical energy. So in this, nothing we have to write. Initial kinetic energy, initial potential energy equals to final kinetic energy, final potential energy. This thing we have to apply. How we are able to apply the conservation of mechanical energy? For this condition is, there is no friction present. There is no friction present. Okay? So whenever you see that the track is frictionless, this wedge is frictionless, there is no friction. So just remember there is a condition or there is a tendency that you can apply the conservation of mechanical energy. Okay. So always remember when frictionless, friction is not there, absent of friction type of thing is mentioned in the question, it is just pushing you to apply the conservation of mechanical energy. Okay. Clear? We can also solve this question by applying the work energy theorem, but it will just increase the length of this question. So we can apply the conservation of mechanical energy. How? So initially, the body at rest, everything is given in the question. You just have to look by your third eye. So initially, is it at rest, which means the initial kinetic energy will become 0. Final initial potential energy के लिए we have to select the reference. So we will select this as a reference frame. Okay. What is this? This is the reference. So from here we are measuring height. So initially this ball is at height h. So potential energy is mgh. Got it? No problem. Final kinetic energy to just to complete the vertical circle. Look, if this ball reaches here at this point, and at this point the velocity will become 0, then there is a tendency that it can complete the circle. Clear? What? No, because if at this place velocity will become 0, the ball will fall down, vertically down. So what we will do? We know that to complete a circle, what is the minimum requirement of the velocity at this point and lower end, it is root 5 G L, where L is the length of the string. Okay. So here it will be 5G D by 2. Clear? Now mgh is equals to 1 by 2 mv square plus final potential energy at this point, it will become 0 because we are at the reference frame. So mgh is equals to 1 by 2 m. V square will become 5g d by 2. Now g and g, m and m will get cancelled out. Got it? So it will become h is equals to 5 by 4 times of d. You can see here there is a match of the option. Option D is the correct one. Clear? So always remember, just to complete a circle, the minimum velocity that you required at the lower end of a circle is root 5 gl. Clear? Maximum तो आप कितनी भी दे सकते हो, maximum तो there is no limit, but the minimum that you have to give is root 5 gl, where L is the radius of the circle. So here the diameter is d, so radius is d by 2, so that is why 5g d by 2. Clear? If anyone has any kind of doubt, you can ask, and it is also from NEET 2023. All the question that you will see here, the previous year's examinations question. Okay. NEET 2023. Now, this one, try to solve this. Try to solve this one. I have given you the formula, what is work done. And here the gravitational force or resistive force, both are constant force. So try to solve this. I'm giving you 1 minute to solve this question. Try to solve this at least. Consider a drop of rainwater having a mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second. Take G constant with a value of 10 meter per second square. The work done by the first gravitational force and second is the resistive force. Tell me. Okay, so firstly tell me, can we apply the conservation of mechanical energy here? Can we do that? Yes and no. Janvi, Mini, Koi, Priya, Darshini, everyone. So let's say this is the track or this is the surface and here is the droplet of water. Okay. It is falling from a height of 1 kilometer. Clear? Now, the mass of this drop is 1 gram. Okay. Okay. Am I audible to you? The screen is visible to you, everyone? Okay. So this drop is falling down with a distance of, with a gap of 1 kilometer. Okay. So this is H. So we can apply the work done by gravitational force, which is G. The force, weight force will acting downward, mgh, and the displacement is also happening in the downward direction. So we can say that it is mgh cos 0, because the angle between mg force and displacement is 0 degree. Cos 0 is 1. So weight work done by the gravitational force is mgh, which is nothing but the potential energy of it. So m is 1 gram, which is 1 into 10 raised to the power minus 3 kilogram. Gravitational acceleration is 10 and height is 1 kilometer, which is 1000 meter. This and this will cancel out. So it will become 10 joule work done by gravitational force. Okay, clear? So by the option you can see easily कि option C is the correct one, because here the minus 10 is mentioned, but we got the plus 10. So plus 10 is mentioned only on option C. So the work done by frictional force is minus 8.75. You can also do these types of question by your reasoning ability. Okay, clear है? Now I will come back to this question after I will tell you something about the work energy theorem. Okay, then we will solve what is the work done by this resistive force. Clear? Now this one, try to solve this. This is very easy. A particle moves from a point minus 2 I cap plus 5j cap to 4 I cap plus 3k cap when a force of 4 I cap plus 3j cap Newton is applied. How much work has been done by the force? So what is given in the question? Given data, firstly you write and try to solve it. Just guess the answer. What is the option? A, B, C or D? Okay. Given data is that initial point x initial is minus 2 I cap plus 5j cap. Final point is 4j cap plus 3k cap. Okay. So what is the displacement vector? Delta x is x final vector minus x initial vector. So it is 4j cap plus 3k cap minus 2 I cap plus 5j cap. Okay. So it will become 4j cap plus 3k cap minus plus 2 I cap minus 5j cap. Clear है? So देखो 4j cap minus 5j cap will become what? So it is 2 I cap minus j cap plus 3k cap. This is the final displacement of the object or the particle. Now we know that work done is given by F vector dot D vector. This is the dot product. F vector is what? 4I cap plus 3j cap. Clear? Dot product with displacement vector, which is 2I cap minus j cap plus 3k cap. Now it's very easy to have a dot product between two vectors. Only the component which is present in both, you have to multiply the coefficient of these vectors. So here I is present in this, I is also present. So we take 4 to the 8. Now j is also present in this and in this also. So here j component is 3 and here the component is minus 1. So it will be minus 3. So what it will become? 8 minus 3 will 5 joule. Okay. So work done by this force is 5 joule. Clear hai? Any kind of doubt in this? Option D is the correct one. Have any one of you got this answer? JNV Mini Koi, Priyadarshini. JNV Gadchiroli is also here. Bhavnagar, Bandara, Vijayalakshmi, JNV Kolhapur. Everyone has to respond. Yaar. Shamita is also here. Try to respond in the chat box. Try to solve the questions. Okay? In that way, this session is going to help you. Clear? Move to the next question. Now we will talk something about the work energy theorem. Work energy theorem is a theorem which helps us to calculate work. Okay? With the help of change in kinetic energy. Okay? So as you can see the statement here, the principle of work and kinetic energy, also known as the work energy theorem, states that the work done by sum of all the forces which is present in the system. So whatever the forces are applied to the system or the particle, it's equals to the change in the kinetic energy of the particle. So whatever the forces a system experiences, it will equals to the change in kinetic energy of the system. Clear? Now, if you will see here that this is a block, this block of mass m is being placed from this point to this point. The displacement is d. Okay? And the velocity here is initial velocity is vi, final velocity is vf, which means there is a change in velocity also because of the presence of this acceleration. and acceleration is caused by which? What? Acceleration is only caused by a force. F is equals to ma. Okay, so that is why if a force is being applied and a particle displaced, it changes the velocity. It changes the velocity, changes the speed, which means it's changing the kinetic energy of the system. So that is why the work done by each and every force present in the system is equals to the change in kinetic energy of the system. Clear? Now, here work done net is equals to delta K, K final minus K initial. Now try to solve a question by this. An object moving along horizontal x direction with kinetic energy 10 joule is displaced through x is equals to 3 I cap meter by the force F vector is equals to minus 2 I cap plus 3 j cap. The kinetic energy of the object at the end of the displacement x is. So firstly, we will write the given data. What is the given data here? देखो सबसे पहले क्या गिवन है? फोर्स वेक्टर गिवन है, तो उसे लिख लो माइनस 2 आई कैप प्लस 3 जे कैप न्यूटन. ठीक है, उसके बाद डिस्प्लेसमेंट वेक्टर गिवन है. कितना डिस्प्लेसमेंट है? एक्स इज इक्वल टू 3 आई मीटर, 3 आई कैप मीटर. द काइनेटिक एनर्जी ऑफ द ऑब्जेक्ट एट द एंड ऑफ द डिस्प्लेसमेंट एक्स इज. ठीक है, सो कहां से स्टार्ट हुआ है डिस्प्लेसमेंट? एक्स इज इक्वल टू 0 से अलोंग हॉरिजॉन्टल एक्स डायरेक्शन में मूव कर रहा है एंड एक्स इज इक्वल टू 3 पे दिस डिस्प्लेसमेंट एंड्स. ठीक है, क्लियर है? सो पार्टिकल कितना डिस्प्लेसमेंट हुआ? 3 आई क्या? क्लियर है सभी को? नाउ what we are going to do, we are going to do calculate the work done. ठीक है, we are going to calculate the work done over here. Work done is f vector dot d vector. ठीक है, f vector is given by minus 2 I cap plus 3 j cap dot product with 3 I cap. So only I and I component will multiply. So it will be minus 6 joule. So work done is coming out as minus 6 joule. ठीक है, so we can say that work done is nothing but delta K, change in kinetic energy. ठीक है, now the kinetic energy of the object at the end of the displacement. So at x is equals to 0, what is the kinetic energy? 10 joule, which is given in the question also. So we can say that net work done is equals to K final minus K initial. ठीक है, very good Vijay Lakshmi. We will see the answer if you are correct or not. So work done here is minus 6 joule. Final kinetic energy we want to know. Minus initial kinetic energy is 10 joule. So kinetic energy final will become 10 will come to this side will become plus. So plus 10 minus 6 will become 4 joule only. So final kinetic energy is 4 joule. Clear hai Vijay Lakshmi? Check your calculation first. Very good Priyadarshini, GNV Mini Koi. You just have to check your calculation again. Okay. Okay. Chalo. Now this question, try to solve this. Try to solve this one. चलो इससे पहले ना the question that we have left, this one, try to solve this one, the second part of it, resistive force of it. So in this question we are going to apply the work energy theorem, which is work done net is equals to change in kinetic energy. Net work done is work done by gravitational force plus work done by the resistive force is equals to change in kinetic energy. ठीक है, so K final minus K initial we can write it. Initially when the rain is dropped, ठीक है, this rain droplet is falling, So it starts falling from a zero velocity. It's a free fall. So initial kinetic energy will be zero. Work done by gravitational force is 10 Joule plus work done by resistive force we want to calculate, and the velocity when it hits the ground is given to you here. At the velocity is given as 50 meter per second. So we can say 1 by 2 times mv square. M is 1 into 10 raised to the power minus 3 and v square is 2500. Okay. So we can say that this will become, we can say that this is 2.5 into 10 raised to the power 3, 10 raised to the power minus 3. ये cancel हो गया, divided by 2. Sorry guys, this is the lack of space. So 10 plus work done by resistive force is equals to 1.25 divided by 2, 1.25. So work done by resistive force is what? Echo. It will become, when you take this 10 at this side, it will become minus 10 plus 1.5, which is minus 8.75. So correct option is option C. This is how we are going to apply the work energy theorem. So have anyone any kind of doubt in applying the work energy theorem? If no one has any kind of doubt, try to solve this. Try to solve this one. An object falls from a height of 10 meter above the ground. After striking the ground, it loses 50% of its kinetic energy. The height up to which the object can rebound from the ground is. Try to solve this. Very good question. And all the questions are from previous years. Let's say this is the ball. Initially, it is falling down and rebounding I'm showing here. Rebounding happening on the same plane, same line, but I'm showing it here for your better understanding. So let's say rebounding happens to this point. Okay. After rebounds, the ball will reach this point. Clear? SA and then S. Now, this height is what? 10 meter. This height we want to calculate. Let's say this height is H. Okay. After striking the ground, it loses 50% of its kinetic energy, which means when it start rebounding, it starts with half of its kinetic energy. Clear? When it starts rebounding, it starts with half of its kinetic energy. Now, what is the kinetic energy it holds? So we can say, you can already calculate the speed of it here. What is the speed? But mass is not given, so we can do one thing, work energy theorem. So work is only done by the gravitational force. There is no other force mentioned here. So we do not have to consider other forces. So work done by gravitational force is acting downward, which is mg. Clear? So mgh is equals to delta k will become initial kinetic energy is 0. So it is 1 by 2 mv final square. The final velocity when it is hitting the ground. Okay. M and M will get cancelled out. G is 10. H is also 10. 1 by 2 v final square. So it will become v final is what? 10 root 2 meter per second. Okay. No. JNV Haveri, it will not reach back to the 10 meter again. Okay. No. Okay. So when it's rebounding with half of its kinetic energy. So initial kinetic energy, let's say K at this process. When it's rebounding, at rebounds, the kinetic energy, let's say K dash will become K minus K by 2. 50% is reduced. So it is happening with K by 2 only. Okay. So with this kinetic energy, up to which height it will go, You have to calculate that. Okay. Now you can say that this is the final velocity. Apply this theorem, work energy theorem, again for this only. So work energy theorem, work done is 1 by 2 change in kinetic energy. So work done is given by mgh. Kinetic energy is half k by 2 only, because change of kinetic energy is k by 2. So k by 2 we can write 1 by 4 mv final square. Okay. So 1 by 4 is what? M and M will get cancelled out. G H is become V final square by 4G. Now you put the value of V final, which is 10 into 2. 100 into 2 it will become, or 200 you can say directly. So it will become 200 by 4. Okay. Which is, no, we have made some mistake here. Somewhere we have made some mistake. That is why it is not coming 5.0. The correct option is 5.0. Okay. So just check where we have made the mistake here. Work done is change in kinetic energy. Initial kinetic energy is 0. Final is half mv final square. M and M got cancelled out. G is 10 meter per second. H is also 10. 10 into 10 is 100. It will become 200. So V final square is 200 only. Then after rebounds, the change in kinetic energy is k minus k by 2, 50%. So it starts its motion with k by 2. Okay. Okay, I got this. Okay. देखो, it is 4G na. 10 is also here. So this 10 will cancel out this. So 5 meters. So there is no mistake. We just forgot to put the value of G here. Okay. Now, everyone got this? Correct option is option D. Now we will look into the power. You can enjoy this animation. Power is nothing but the rate of work done. Rate of work done is power. So power is given by E is equals to W by T. There are two types of power. Instantaneous power. Like this bulb is having an instantaneous power. That's why it is dancing. Instantaneous power is given by dW by dt, and the average power is given by delta W by delta T. We can also calculate the power in terms of force and velocity. So power is W dW by dt. We can say that dW is nothing but F dot dx divided by dt. So we can say this is F, dx by dt is velocity. So we can say that F v cos of theta, which means only the tangential component will come of the velocity or the force in power. So suppose there is an object which is having this type of force, which an angle theta. This is F cos theta and this is F sin theta. So only this component, which is in the direction of displacement or velocity, is responsible for the power generation. Okay. Now, try to solve this question. At any instant of time t, the displacement of any particle is given by 2t minus 1 under the influence of a force 5 Newton. Force is constant, displacement is variable. The value of instantaneous power is, already told you how to calculate this. Displacement is given by x is equals to 2t minus 1. So all you have to do, you have to calculate the dx by dt, which is what? 2, 2 only. So power is nothing but f dot v. Okay, both are in same direction. So it is f, which is 5 Newton, multiply velocity is 2, which is 10 watt. The unit of power is watt. Very good. And this is NEET 2020. So tell me how many of you got this? Chalo. Now try to solve this question. A particle moves with a velocity this and horizontally under the action of a constant force this. Now instantaneous power supplied to the particle. I have told you that F is nothing but, sorry, power is nothing but what? F vector dot V vector, the dot product. Now this is 5 I cap minus 3 j cap plus 6 k cap. Dot product with 10 I cap plus 10 j cap 20 k cap. So same will multiply. 5 into 10 is 50, minus 3 into 10 is minus 30, 6 into 20 is 120. Okay. Now it will become 140 watt. Option D is the correct. Any kind of doubt, guys, in this question? Any kind of doubt? Okay. There is one more question here. So this topic is work done by spring force. So work done by spring force. Work done by spring force or energy, potential energy stored in it is given by 1 by 2 k x square. Always remember, it's also equals to potential energy stored in. Potential energy stored. Okay. Now here you will see the potential energy of a long spring when stretched by 2 centimeter is U. If the spring is stretched by 8 centimeter, what is the potential energy stored in it will be? So for 2 centimeter, it is U, which is 1 by 2 times of K x square, 2 into 10 raised to the power minus 2 square. U is 1 by 2 times K into 4, 10 raised to the power minus 4. This one, clear? So this is U 1 by 2 times K into, and this, this will become not 1 by 2. It is 2K into 10 raised to the power minus 4 Joule. Now, when it is stretched by 8 centimeter, so you can say U dash will become 1 by 2 times K x square. 1 by 2 times K x square is what? X is 8 into 10 raised to the power minus 4 square. Now, 1 by 2, put the value K into 64, 10 raised to the power minus 4. Cancel it by 2, it is 32. So you can see that 2K is a multiple of 32K and 2K. So if you multiply 16, this 2K, if I just multiply in the previous expression by 16, I will get the U dash. So U dash is nothing but 16 times of option C is the correct. Okay. I hope you have enjoyed the session. If anyone has any kind of doubt, you can ask related to anything. Okay. You can ask me. Anyone, any kind of doubt, guys? Yes and no? Okay. So now we will end the class. I'll just sharing a poll with you. Just quickly answer in that poll and then you can leave the class. Okay. And try to answer all of the question present in the poll. Okay. I have launched the poll. Just try to answer it. ठीक है, एनीवन एनी काइंड ऑफ डाउट यू कैन आस्क। ठीक है, थैंक यू सो मच गाइस।